Now here's where we are after getting the zeros in the first column. We want to leave those. We don't want to mess with those. But we want to get a 0 here. Now how are we going to do that? Well, again, we also want a 1 here. And it's going to be easier to get the 0 here if we've already got a 1 here, fewer signs to worry about, and no fractions. So what we do is we first get our 1 by multiplying the second row by -2. If we multiply the -1/2 by -2, it'll give us 1. 16 times -2 gives us -32. -5.5 times -2 gives us 10 halves. 1 times -2 gives us -2. Third row is just repeated. Now that we have the 1, we can easily get a 0 here. If we add 4 times the second row to the -4, 4 times the 1 to the -4, we're going to get the 0. So we add 4 times the second row to the third. Okay, so 4 times 1 is 4, and -4 gives us 0. 4 times -32 is -128, plus 1 gives us -127. 4 times 10 halves is 20 halves, or just 40 halves, or just 20. We add that to -1, we get 19. 4 times -2 is -8, which we add to 0 to get -8. And 4 times 0 is 0, plus 1 gives us 0. And you see where these numbers come from. Okay, we've made some notations here, some annotations, but we've already showed where these numbers come from. So these annotations are here so that what I type into the class notes will be clear. This last row represents 127z equals something, so that z equals, and we want to get z equals something. Now this doesn't really represent -127z equals all this stuff, but we can think of this as like a -127z equals. We want to get a z equals. In other words, we want to get a 1 here. Okay? And of course, to get the identity matrix, we do want a 1 in this position. And that's going to be very easy to get. We simply divide this row by -127. When we do that, everything in the row is multiplied by the -127, and this is the row we get. And you see we got all these 127s in the denominator. This is where the fractions get a little bit ugly, but we're going to proceed. Okay, so you see that our identity matrix is starting to form here, but we need zeros in these positions. How are we going to do that? Well, the procedure is fairly simple. That doesn't mean it's not somewhat tedious, because we've got all these fractions to deal with. But what we're going to do is we're simply going to see that we want a 0 here. We don't want to mess up our 1s and 0s over here. So we simply add 32 times this row to this, and we'll get a 0. And we add 2 times this row to this one, and we get a 0. Now, the complication is that's real easy. So we do the second row plus 32 times the third to get our 0. In the first row, plus 2 times the third to get a 0 here. So we'll have -32 plus 32 times the third to give us 0. -2 plus 2 times the third to give us 0. Of course, we've also got to do the 10 halves plus 32 times the -19 127ths. And then we're going to have to do 1/2 plus 2 times the -19 127ths. And that gets a little complicated. So I'm just putting an etc. down here. I'm not going to go through all the calculations with all the fractions. You can either do fractions by this point or you can't, and if you can do them, it's not really a problem. It's just kind of a boring and tedious job, and one you got to be real careful about or you make a mistake. We then Didn't write what we did here, but it's fairly obvious. Okay, we want to get rid of this 3/2, so we're going to subtract 3/2 of the second row from the first. So we should read here 3/2 of the second row minus the first, and it'll give us this. Now, having completed all those steps, we end up with the form that we wanted. Identity matrix on the left, and this mess of fractions on the right. And this mess of fractions here is the inverse of our original matrix. So that the inverse of that A matrix that we started with is here. We've reduced the A matrix to this. We started with the identity over here, and now we're down to the A inverse matrix.